All right, welcome back, everyone. This is going to be a real quick video covering section 10.6 on exercise and muscle performance. So I think it's pretty interesting, and I just wanted to go over it with you so you know what's going on. So the first thing I want to talk about are just three terms. Um, when we add structural proteins, that's called hypertrophy, and that increases the cell diameter of muscle cells. That's, you'll see, building muscle basically. And then the reverse is that when you have structural proteins that are lost and your muscle mass decreases, that's called atrophy. And then if that atrophy is age related, we call it sarcopenia. And so basically you can get to a certain age where even if you're able to still work out, you're still going to lose muscle mass just due to senescence or the breakdown of your muscle over time. We call that sarcopenia. So let's talk about two different types of exercises and how differing the types of muscle fibers that they have can help do do better for those exercises. So the first is the endurance exercise, and basically any exercise that you would do over a very long time. And we know from our last lecture that slow fibers would be better to do these types of work. Fibers that don't require a lot of force but can work for long amounts of time without getting tired. Um, when we use slow twitch fibers, like I said, they're able to maintain contractions over long periods. And if you endurance train, you can make them even more efficient by producing more mitochondria, which enables them to use more aerobic metabolism, making more ATP essentially. Endurance exercises also increases the amount of myoglobin in the cell, and myoglobin acts as an oxygen storage supply for the mitochondria. That same type of training, let's talk about marathon running, for instance, can also increase capillary networks, a process that we know is called angiogenesis, or the production of more blood vessels. And that supplies oxygen and removes metabolic waste from those muscles. And so just continues to allow those muscles to be working for long periods of time without fatiguing. Um, if you So one interesting thing I think this brings up is they are still unsure if the better runners, some people are just naturally better runners than others. We don't know if that is because people are born with with naturally higher slow oxidative fibers, or whether they develop them just because they are doing repetitive training. So I think it's interesting that we still aren't really sure. I would assume that, if you, even if you're not a good runner now, if you train yourself, you can definitely build up some more slow oxidative fibers to make yourself go for longer distances. Um, and then, of course, with anything, you should be careful when doing endurance training, because this type of training can obviously result in overuse injuries like stress fractures and joint and tendon inflammation. And so, obviously, you want to observe best practices and give yourself recovery periods as well. The next type of exercise is the resistant exercise, maybe some that we're more familiar with if you go to the gym. Um, they require large amounts of those fast glycolytic fibers, because those fibers are best at producing those short, powerful movements that you don't repeat over very long periods, right? Like lifting weights, doing push-ups, and things like that. You can do those short, those powerful movements, but you can't do them for very long. Um, so I think it's just interesting to point out that resistance exercise affects muscles by increasing the formation of those myofibrils, and basically what that means is they increase the thickness of the muscle fibers. If you have more myofibrils, the fibers itself will increase in thickness. This is called, again, hypertrophy. So you can see this bodybuilder right here has built up his muscle mass, and that is called hypertrophy. Um, what else is interesting here? There's usually no significant increase in mitochondria or capillary density. So instead of these endurance exercises where you are increasing mitochondria and capillary density, that doesn't happen with this type of exercise. However, it does increase the development of connective tissue, which adds to the overall mass of the muscle and helps to contain muscles as they produce those really powerful contractions. You can also increase the strength of your tendons, and that's great because, like we know, tendons attach muscle to the bone. And so I think that's where I'm going to stop with that. There's a few bit more information here. The last thing is the performance enhancing substances. We've all heard about different substances that athletes take in order to get an advantage. The first one they talk about is anabolic steroids. If you know anything about Major League Baseball, that was a huge sort of scandal that happened in the late 90s and early 2000s, where the Major League Baseball players we're taking anabolic steroids, and that is a sex hormone, the male sex hormone, that produces male secondary sex characteristics. But if you take extra of it, it can stimulate that even more, which includes more muscle formation and basically being able to hit the ball a really long way, and also being able to make sure that you don't get injured as easily. And so that's just one I think is interesting to talk about. And then we have things like endurance athletes. They also use performance enhancing substance. One that I can most easily point out is Lance Armstrong. He used a lot of substances that could help his aerobic respiration, or basically increase oxygen levels in the blood. And so that's another one. Sometimes you'll hear about people using human growth hormone. That's another supplement that athletes use, because not only can it facilitate body mass, it also promotes healing so that you're just not as beat down after doing a strenuous exercise. Um, Anyway, I think that's where I'm going to leave it here, and we will be back after this with 10.7, 10.8, and 10.9.